Most people think a smart yard means scheduling sprinklers and adding a few motion lights. Then they discover their irrigation controller floods the lawn during rainstorms, their security cameras disconnect every time the weather shifts, and their robotic mower starts up at 6 a.m. on Saturday morning. Real yard automation isn't about piling on devices, it's about creating a system that responds to actual conditions, coordinates across categories, and stays invisible until you need it. My name is Keiko Tanaka, and I specialize in what I call invisible intelligence, integrating smart technology so seamlessly into spaces that it enhances your life without disrupting the look or feel of your home. You're listening to Smart Home Setup Podcast. Quick note before we dive in, everything you hear in this episode, the research, the data, the script, is human-written and verified by real authors who know this stuff inside and out. The voice delivering it is AI-generated, which lets us get these episodes out consistently without sacrificing depth or accuracy. Just wanted to be upfront about that. If you've been listening for a while, thank you. I know there are a lot of smart home podcasts out there, and I'm glad this one is landing for you. If you're new here, welcome. I hope this becomes a go-to resource as you build out your setup. New episodes come out every Monday, Wednesday, and Friday, so there's always something fresh to work with. All right, let's jump into today's episode. A smart yard should feel like an extension of the home's interior rhythm, responsive, intuitive, never demanding attention. This Smart Yard Automation Setup Checklist covers the foundational elements, protocol considerations, and invisible integration strategies for outdoor spaces that anticipate needs rather than broadcast their intelligence. Whether you're orchestrating irrigation based on soil moisture or concealing motion sensors in architectural trim, this checklist ensures every device, hub, and automation logic works cohesively before installation begins. Now let's talk about the essential infrastructure and protocol foundations. Before any device touches soil or mounts to siding, the invisible backbone must be in place. Outdoor automation demands more robust connectivity than interior spaces. Weather interference, distance from routers, and metal structures all degrade signals. Start here. You'll want a Wi-Fi extender or outdoor mesh node positioned within 30 feet of your farthest device. Wi-Fi-based irrigation controllers, cameras, and outdoor lighting strips lose connectivity beyond this threshold, resulting in 3 to 5 second automation delays or total dropout during rain. Test signal strength at each planned device location using a smartphone app before mounting anything permanent. If your primary router sits at the front of the house and irrigation valves hide near the back fence, a weatherproof mesh node bridging that gap prevents the frustration of automations that fire inconsistently. If you're mixing protocols, you'll need a Zigbee or Thread border router. A Zigbee mesh requires at least 3 powered nodes, not battery devices, to maintain reliable outdoor coverage, while Thread relies on border routers like the Apple HomePod Mini positioned near windows facing the yard. Z-Wave operates at a lower frequency, 908.42 MHz in North America, and penetrates walls more effectively, but fewer outdoor devices support it in 2026. Document a hub compatibility matrix before purchasing any device. Not every Zigbee controller speaks to every Zigbee sensor, and Matter 1.4 adoption remains inconsistent across landscape brands. Create a spreadsheet listing each planned device, its protocol, Zigbee 3.0, Matter over Thread, Wi-Fi, proprietary, required hub or bridge, and confirmed compatibility with your existing ecosystem. The frustration of a $400 sprinkler controller that won't integrate with your home automation platform is entirely avoidable with upfront verification. Even outdoor-rated electronics degrade when subjected to direct sun, temperature swings, and moisture infiltration.
A recessed niche in exterior siding, a ventilated utility box tucked under eaves, or a hidden compartment within landscaping stonework keeps hubs functional while invisible. I've seen too many projects where a Zigbee coordinator mounted proudly on a garage wall became a blistered, non-responsive eyesore within 6 months.
Consider backup power for critical devices. Battery backup for irrigation controllers ensures scheduled watering continues during brief power outages, while security cameras benefit from UPS systems that provide 4 to 6 hours of runtime. Document which devices have built-in battery failover. Many smart locks and sensors do, versus those that go dark immediately. Map cable pathways and conduit before trenching or drilling. Low-voltage landscape lighting, sensor wiring, and camera power runs should follow deliberate routes that avoid future digging zones or irrigation line placement. Bury conduit 6 to 8 inches deep to protect from shovel strikes, and photograph the pathways before backfilling. You'll thank yourself when troubleshooting connectivity issues months later. Define latency tolerance per automation type. Motion-triggered security lighting demands sub-500 millisecond response times, while irrigation schedule adjustments can tolerate 5 to 10-second delays. Wi-Fi devices average 800 milliseconds to 2-second latency. Zigbee typically achieves 200 to 400 milliseconds, and Thread can hit 100 to 200 milliseconds when properly meshed. Match protocol to use case rather than choosing based on brand loyalty or price alone. Verify the IP rating for every outdoor device. IP65 withstands rain and splashing, but not submersion. IP67 tolerates brief immersion. IP68 handles continuous submersion. A sensor rated IP44 will fail within a season if mounted where sprinklers directly hit it, regardless of how waterproof the marketing claims. The manufacturer's official specifications matter more than generic promises. Moving on to irrigation and water management components. Water automation requires more nuance than simply scheduling timers. Soil type, sun exposure, plant water needs, and weather patterns all influence whether a smart system conserves resources or floods flower beds. These components transform reactive watering into responsive hydration. Look for a smart irrigation controller with local weather API integration. Controllers that pull real-time precipitation data and forecast information via Wi-Fi connection to services like Weather Underground or NOAA feeds skip scheduled watering when rain has already saturated soil or storms approach within 6 hours. The automation logic should follow. If rainfall in the last 24 hours equals or exceeds a quarter inch, or if the forecast for the next 6 hours calls for rain, then skip scheduled zone watering. Otherwise, proceed with the zone schedule. Install soil moisture sensors per irrigation zone. Battery-powered Zigbee sensors buried 4 to 6 inches deep report actual moisture levels rather than relying on generic schedules. Automation logic becomes, if Zone 1 moisture is less than 25% and air temperature is above 55 degrees Fahrenheit, then activate Zone 1 for 15 minutes. Check moisture after 30 minutes. If moisture is still below 30%, extend watering for another 10 minutes. This prevents overwatering clay-heavy zones while ensuring sandy areas receive adequate saturation. Sensors should report at least every 2 hours during growing season. Anything slower risks missing critical dry periods. A flow meter detects leaks and system faults. A Wi-Fi-enabled flow sensor installed in-line before zone valves monitors water volume per cycle. The system learns baseline flow rates for each zone, then triggers alerts when consumption exceeds expected parameters by 15% or more, usually indicating a broken sprinkler head, cracked line, or stuck valve. Invisible automation, if Zone 3 flow exceeds baseline by 15%, then send an alert and pause watering for Zone 3 and log the incident timestamp. Install a master valve with fail-close behavior. If connectivity drops or the controller loses power mid-cycle, a fail-close master valve prevents water from running indefinitely.
This single component has saved more water and prevented more flooding than any other in outdoor smart systems. Verify the valve's default state before installation. Some cheap models fail open, which defeats the entire safety purpose. Use a rain sensor override with 24-hour delay reset. Physical rain sensors, simple mechanical devices, provide redundancy when internet connectivity fails. Mount them 10 to 15 feet from structures to avoid false positives from roof runoff, and set logic to prevent watering for 24 hours after activation. If the rain sensor triggers, then pause all zones for 24 hours and reset the timer when the sensor dries. This complements API-based weather integration rather than replacing it. Provide manual zone control with 15-minute auto shutoff. Physical buttons or a wall-mounted panel concealed inside a garage or utility area allow watering without phone apps or voice commands. Each zone activation should auto-terminate after 15 minutes unless manually extended, preventing forgotten hoses from flooding foundations. The automation is, if the manual zone button is pressed, then activate the zone for 15 minutes. If no extension input is received at the 14-minute mark, then begin the shutdown sequence. For pump-based systems, use energy monitoring. Properties using well water or booster pumps benefit from smart plugs with energy monitoring that track pump runtime and power consumption. Sudden spikes indicate mechanical issues. Gradual increases suggest declining efficiency. Now, let's get into lighting and ambiance automation.
Outdoor lighting should respond to human presence and natural light transitions, not simply turn on at 7 p.m. regardless of sunset's seasonal shift. The goal? Illumination that feels intuitive, as if the space itself anticipates use. Integrate a dusk-dawn sensor with geolocation data. Rather than fixed timers, lighting should activate when actual ambient light drops below a measured lux threshold, typically 20 to 30 lux for pathway lighting, 5 to 10 lux for accent lighting, while also considering your home's specific GPS coordinates for accurate sunset calculation. Automation: if ambient lux is less than 25 and the sun's position is more than 6 degrees below the horizon, then fade in pathway lights over 10 minutes. This prevents lights from glaring unnecessarily during bright summer evenings while ensuring they're already on during overcast winter afternoons. Position motion sensors for a 15-foot detection radius. Zigbee or thread motion sensors mounted 7 to 8 feet high at entry points detect approaching people 15 feet away, allowing lights to fade on before anyone reaches the door, rather than triggering abruptly when already standing in darkness. Battery-powered sensors should report every 30 to 60 seconds and have 18-month battery life minimum. Shift color temperature based on time and context. Zigbee-based outdoor fixtures can transition from 4,000 Kelvin cool white during dinner preparations, enhancing visibility for grilling or outdoor cooking, to 2,700 Kelvin warm white during late evening conversation, then to dim amber, 2,200 Kelvin, after 10 p.m. to reduce light pollution and preserve night vision. Logic: if the time is between 6 p.m. and 8:30 p.m., set temperature to 4,000 Kelvin. If the time is between 8:30 p.m. and 10 p.m., transition to 2,700 Kelvin over 15 minutes. If the time is 10 p.m. or later, set 2,200 Kelvin at 30% brightness. Use zone-based activation rather than all-or-nothing control. Divide the yard into functional zones: pathway, deck, garden accent, driveway, security perimeter, and automate each independently. Motion at the front door activates entry lighting without illuminating the entire yard. Deck occupancy detected via pressure mat sensor or secondary motion device brings up ambient string lights while leaving garden spots off. This prevents visual clutter and energy waste while maintaining responsive illumination where actually needed. Integrate astronomical clock functions for seasonal shifts.
Rather than manually adjusting schedules 4 times yearly, astronomical clock functions built into most Zigbee hubs and matter controllers automatically adjust activation times as sunset and sunrise shift throughout the year. The system recalculates daily based on your latitude and longitude, ensuring lights never come on too early or stay off too late during seasonal transitions. Plan for failover to motion-only mode during hub outages. Higher quality Zigbee lights retain local motion sensing capability even when disconnected from the hub, reverting to basic motion detected equals turn on for 5 minutes logic. Verify this behavior during your device comparison research before purchasing. Cheaper Wi-Fi bulbs often become completely non-functional when internet drops, leaving outdoor areas dark despite having powered fixtures. Hide sensors within architectural elements. Motion sensors embedded in post caps, concealed behind downspout brackets, or tucked into eave trim maintain functionality without broadcasting their presence. I once integrated motion sensors into decorative corbels flanking a garden gate. Guests never noticed them, but the pathway always illuminated 3 seconds before they arrived. The principle: technology should be felt, not seen. Let's move on to security and monitoring systems. Outdoor security automation must balance awareness with privacy, capturing genuine threats without creating surveillance anxiety for family or neighbors. These elements provide layered protection that escalates response appropriately. Choose a subscription-free camera system with local storage. Wi-Fi cameras writing to network video recorders or micro SD cards avoid monthly fees while maintaining 24/7 recording. Motion-triggered clips should upload to secure cloud storage if desired, only when specific zones detect activity, reducing bandwidth consumption and false alerts. Set up geofencing automation for armed and disarmed states. Security cameras and motion sensors should automatically arm when the last family member's phone exits a 200-meter geofence radius, then disarm when anyone returns within that boundary. Logic: if all family member devices are more than 200 meters from home, then arm the security system after a 5-minute delay. If any family device is within 200 meters, then disarm exterior cameras but maintain perimeter sensors. This prevents constant notifications about your own movements while maintaining protection when the property is vacant. Create distinct detection zones with variable sensitivity. Divide camera views into regions: high sensitivity for doorways and windows, medium for pathways, low or disabled for street-facing areas where passing cars trigger false alerts. Most systems allow polygon-based zone drawing. Spend time refining these boundaries to eliminate tree branches swaying into frame or headlight sweeps from neighbor driveways.
Require two-factor verification before security automations execute. Rather than immediately sounding alarms when motion is detected at 2 a.m., require confirmation from a second sensor type, door contact sensor, glass break detector, or secondary camera within 10 seconds before escalating to alert or alarm state. This logic prevents raccoons or wind-blown debris from triggering full security responses. If motion is detected in the perimeter zone, then monitor secondary sensors for 10 seconds. If a door sensor triggers or glass break is detected, activate the alarm. Otherwise, log it as a non-threat. Implement progressive notification escalation. First motion detection logs an event. Second detection within 5 minutes sends a push notification. Third detection within 10 minutes triggers a siren and notification to secondary contacts. This prevents alert fatigue while ensuring genuine intrusions receive appropriate attention. The system learns baseline activity patterns. Delivery drivers typically appear between 10 a.m. and 6 p.m. and adjusts sensitivity accordingly. Place cameras invisibly within functional objects. Security cameras integrated into light fixtures, mounted within birdhouse enclosures, or positioned behind one-way mirror panels in outdoor cabinetry provide surveillance without overt intimidation. A camera doesn't need to be visible to be effective. In many contexts, concealed placement captures more genuine behavior because subjects don't alter their actions in response to obvious recording. Test latency for time-critical automations. Motion detection that takes 3 to 4 seconds to trigger lighting or recording may miss critical moments. Test actual response times using your specific hub, devices, and automation logic under various network load conditions. If latency consistently exceeds 1 second for security-critical triggers, consider switching from Wi-Fi to Zigbee or Thread devices, or implementing local automation rules that don't require cloud processing. Now, robotic and autonomous equipment integration. Robotic mowers, pool cleaners, and autonomous yard tools represent the most visible category of smart yard automation, yet even these can integrate more thoughtfully than simply scheduling runtime. Proper connectivity transforms them into isolated appliances into responsive system components. Enable hub integration for coordinated scheduling. A robotic mower should communicate with the irrigation controller to avoid mowing saturated grass, which tears turf and clogs blades, and with weather APIs to return to dock before storms. Automation. If irrigation for all zones completed within the last 4 hours, or if soil moisture for all zones exceeds 60%, then delay mower start by 6 hours. If precipitation forecast for the next 2 hours exceeds 40%, send the mower to dock. Not all robotic equipment supports this level of integration. Verify Matter, Zigbee, or proprietary API availability before purchasing. Bury perimeter wire at proper depth and test voltage. Robotic mowers rely on boundary wire buried 2 to 4 inches deep. Too shallow and it surfaces after frost heave. Too deep and signal weakens. Use a wire break detector to verify continuous circuit before covering pathways and map wire routes photographically. The automation fails entirely if perimeter signal drops. There's no graceful degradation here. One poorly installed splice will cause the mower to randomly stop and beep for attention at 6 a.m. Schedule operation that respects noise ordinances and household routines. Even quiet robotic mowers produce 60 to 65 decibels, conversation-level volume, that becomes intrusive during outdoor dining or video calls. Schedule operation during typical absence windows. If it's a workday and the time is between 9 a.m. and 3 p.m. and there's no manual override, then begin mowing cycle for Zone 1. Include manual override capability via button, app, or voice command, so spontaneous yard use doesn't require fighting with a robot mid-cycle. Use energy monitoring to detect mechanical issues early. Smart plugs monitoring charging dock power consumption reveal declining battery health, longer charge times, or motor inefficiency, higher runtime power draw, months before catastrophic failure. Track baseline metrics after installation, then set alerts for 15% deviations from normal patterns. Add rain sensors that pause autonomous equipment. Beyond irrigation, robotic mowers and pool cleaners should halt operation when precipitation is detected. Mowing wet grass damages turf and dulls blades. Pool cleaners waste energy when rain is diluting chemicals anyway. Logic: if the rain sensor is active or if rainfall in the last hour exceeds 0.1 inches, then pause all robotic equipment. Resume after surface is dry for a minimum of 2 hours. Implement geofencing to prevent operation when children or pets are present. Advanced systems detect family members' phones within the property boundary and pause potentially hazardous equipment. A robotic mower can injure small pets. Pool cleaners can trap animals. The automation: if a child's device is detected in the yard zone, or if a pet collar beacon is in range, then immediately pause all robotic equipment and send a notification. This requires additional Bluetooth beacons or pet collar sensors, but the safety margin justifies the complexity for households with young children or small animals.
automate fall migration to reduced frequency scheduling. Rather than manually adjusting mowing schedules as grass growth slows, integrate soil temperature sensors, also used by irrigation systems, that automatically reduce mowing frequency when ground temperature drops below 55 degrees Fahrenheit for 3 consecutive days. The grass isn't growing meaningfully at that point. Weekly mowing becomes bi-weekly, conserving energy and equipment wear. Let's talk about climate and environmental monitoring. Smart yards respond to actual conditions rather than assumptions. Wind speed, UV index, soil temperature, and air quality all inform better automation decisions. These sensors provide the contextual awareness that separates reactive systems from truly intelligent ones. Install a weather station with hyperlocal data reporting. Personal weather stations, Wi-Fi or Zigbee connected, mounted 10 feet above ground, measure conditions at your specific property rather than relying on airport data 15 miles away. Temperature, humidity, wind speed, and barometric pressure feed into multiple automations. If wind speed exceeds 25 miles per hour, then retract the awning and delay mower operation. If the UV index is above 8 and the time is after 2 p.m., extend shade sails over the deck. This data also improves HVAC efficiency by triggering window shade adjustments before heat builds inside, a cross-boundary automation that demonstrates the value of integrating indoor and outdoor systems. Use soil temperature sensors for frost protection. Buried sensors reporting soil temperature, often the same devices used for moisture monitoring, trigger protective measures when ground temperature approaches 32 degrees Fahrenheit. If soil temperature in the garden zone is below 34 degrees and the forecasted low air temperature is below 30 degrees, then activate frost protection irrigation at 2 a.m. and send a notification to cover sensitive plants. Brief irrigation before hard freezes can protect root systems in borderline conditions, while alerts allow manual covering of vulnerable plants. Monitor air quality for ventilation automation integration. Outdoor air quality sensors measuring PM 2.5, PM 10, ozone, and VOCs inform whole home ventilation decisions. During wildfire season or high pollen days, outdoor air quality data prevents fresh air intake systems from pulling contaminated air into living spaces. If outdoor AQI exceeds 150 or pollen count exceeds the high threshold, then close the fresh air damper and switch HVAC to recirculation mode and notify occupants to keep windows closed. This bridges outdoor sensing with indoor comfort, a holistic approach that justifies the presence of outdoor sensors beyond yard-specific automations. Install UV sensors that trigger shade deployment. Retractable awnings, motorized shade sails, or adjustable pergola louvers respond to actual UV intensity rather than time-based schedules. Southern exposures may need shade at 11 a.m. during summer, but not until 2 p.m. in spring. UV index sensors capture this variation. If the UV index exceeds 6 and outdoor temperature exceeds 78 degrees and deck occupancy is detected, then extend the awning to 50% and adjust to sun angle every 30 minutes. This automation requires motorized shade systems with Matter or Zigbee control, not common in 2026, but increasingly available as outdoor furniture manufacturers integrate smart capabilities. Add lightning detection for emergency equipment shutdown. Advanced weather stations or standalone lightning detectors sense electrical storms within 20 miles and trigger protective measures. If lightning is detected within 10 miles, then send the robotic mower to dock and retract motorized awnings and pause electric vehicle charging via smart plug and log the storm proximity timestamp. This prevents equipment damage from power surges and protects fabric and mechanical components from wind damage as storms approach. Now, energy management and load balancing. Outdoor automation can become an energy burden if dozens of devices draw phantom loads, charge batteries inefficiently, or operate during peak rate periods. These strategies ensure smart yards reduce rather than increase overall consumption. Schedule equipment charging based on time-of-use rates. In areas with time-of-use electricity rates, shift robotic mower charging, outdoor battery system recharging, and pool pump operation to off-peak hours, typically 9 p.m. to 7 a.m. Automation. If the current time is between 9 p.m. and 7 a.m. and device battery is below 80%, then initiate charging cycle. Otherwise, maintain current state. This simple logic can reduce outdoor automation costs by 30 to 40% in time-of-use rate zones.
Smart plugs on always-on devices to measure actual consumption. Many irrigation controllers, outdoor lighting transformers, and robotic equipment docks draw 5 to 15 watts continuously. Smart plugs with energy monitoring measure actual consumption, allowing you to identify and eliminate phantom loads. An outdoor lighting transformer drawing 8 watts 24/7 consumes 70 kilowatt hours annually, $11 to $14 wasted even when lights are off. A smart plug cutting power during daylight hours eliminates that waste. If ambient lux exceeds 100 and the time is between 8 a.m. and 5 p.m., disable power to the lighting transformer. Integrate solar panel generation with battery storage monitoring. Properties with solar generation benefit from monitoring outdoor automation energy consumption separately from household loads. A dedicated circuit or smart breaker reporting outdoor power draw reveals whether irrigation pumps, outdoor refrigeration, or charging equipment exceed reasonable thresholds. Integration logic: if solar generation exceeds household consumption and battery state exceeds 80%, then prioritize outdoor equipment charging. Otherwise, defer non-critical loads to off-peak hours. Implement dynamic load balancing to prevent circuit overload. When multiple high-draw devices operate simultaneously, pool heater, irrigation pump, outdoor kitchen appliances, smart breakers, or load management controllers prioritize critical loads and defer discretionary ones. If circuit load exceeds 80% of capacity, then pause the pool heater and defer mower charging until load drops below 60%. This prevents nuisance breaker trips and extends equipment lifespan by avoiding voltage sags. Conduct an energy audit revealing outdoor consumption patterns. Before implementing energy management, conduct a baseline audit measuring actual outdoor consumption across categories: lighting, irrigation, equipment charging, decorative features, security cameras. This reveals where optimization will have meaningful impact versus marginal gains. Here's a final check before you go. Print or save this condensed verification list. Check each item before declaring your Smart Yard Automation Setup Checklist complete. Connectivity verified. All device locations tested for adequate Wi-Fi, Zigbee, or Thread signal strength. Hub compatibility documented. Every device confirmed compatible with your specific hub or bridge. Power infrastructure. Outdoor outlets installed, circuit capacity verified, backup power considered for critical devices. Protocol consistency. Devices grouped by protocol with appropriate bridges or border routers positioned. Weatherproofing confirmed. All devices and connections meet or exceed IP65 rating for exposed locations. Automation logic tested. Each if-then rule verified with manual triggers before relying on autonomous operation. Fallback behaviors documented. Known failure modes and offline functionality confirmed for each device. Energy monitoring baseline. Initial consumption measured before automation to quantify future improvements. Physical installation complete. All mounting, burial, and concealment work finished before activating systems. Integration with indoor systems. Cross-boundary automations for security, climate, and energy configured and tested. Manual override access confirmed. Physical buttons, wall controls, or app access for every automated function.
Notification settings refined. Alert thresholds adjusted to eliminate false positives while catching genuine issues. Now let me answer some frequently asked questions. What smart home protocol works best for outdoor yard automation in 2026? Thread and Zigbee 3.0 provide the most reliable outdoor automation in 2026 due to their mesh networking capabilities and lower power consumption compared to Wi-Fi. Thread devices typically achieve 100 to 200 millisecond response times and maintain connectivity through multiple node hops, making them ideal for larger properties where distance from the router exceeds 50 feet. Zigbee works well for irrigation controllers and lighting, but requires at least 3 powered, non-battery nodes to maintain outdoor mesh stability. Wi-Fi devices work for high-bandwidth needs like security cameras, but introduce 800 milliseconds to 2-second latency and can overwhelm router capacity when you're running 8 or more outdoor devices. Matter 1.4 compatibility allows mixing these protocols under unified control, but verify specific device support before assuming cross-protocol functionality. Not every manufacturer has implemented Matter fully, despite claiming compatibility. How do I hide smart yard automation devices without blocking their wireless signals? Concealing outdoor automation devices requires balancing aesthetics with signal propagation. Metal enclosures and dense materials block Zigbee, Thread, and Wi-Fi signals by 40 to 70%, while wood, stone veneer, and architectural foam create minimal interference. Position devices inside decorative post caps, behind lattice panels, or within faux rock enclosures that maintain line of sight to hub locations. For motion sensors and cameras, embed them in eave trim, downspout brackets, or light fixture housings, where their presence reads as architectural detail rather than surveillance. Irrigation controllers hide well in ventilated utility boxes painted to match siding or tucked inside planter boxes with weatherproof lids. The key principle? Test signal strength after concealment but before permanent installation. A device that loses 30% signal strength may still function reliably if it started with excellent connectivity, but a marginal device will become unreliable when hidden. Should I invest in a complete smart yard system or start with one category and expand?
Start with irrigation automation as your foundation, then expand to lighting, security, and robotic equipment in subsequent phases. This staged approach prevents overwhelming complexity while allowing each system to prove reliability before adding dependencies. A smart irrigation controller with soil moisture sensors and weather integration delivers immediate water savings and demonstrates whether your protocol choice, Zigbee, Thread, Wi-Fi, performs reliably across your property's layout and distance challenges. Once irrigation runs consistently for 2 to 3 months without intervention, add motion-activated lighting using the same protocol, which shares the mesh network you've already established and proven. Security cameras can integrate next, followed by robotic equipment that coordinates with irrigation schedules. This staged expansion also spreads costs across 6 to 12 months rather than requiring $2,000 to $4,000 upfront investment, and allows you to pivot protocol choice if early devices prove unreliable. Better to discover Wi-Fi connectivity issues with 3 irrigation zones than after installing 15 devices across multiple categories. The most successful smart yards feel invisible in daily experience. Irrigation happens during sleep hours. Lighting anticipates movement before it's consciously noticed. Security monitoring remains silent unless genuinely needed. This checklist provides the technical foundation, but the real work lies in refining automation logic through observation and adjustment over weeks and seasons. Watch how morning sun hits the deck in July versus September. Notice where motion sensors trigger too eagerly during windy afternoons. Observe which routines actually happen daily versus the ideal schedule you initially programmed. Smart yard automation succeeds not when every possible feature has been enabled, but when the technology recedes so completely that the space itself feels responsive.
a garden that waters itself precisely, pathways that illuminate moments before they're needed, security that protects without performing. Start with this smart yard automation setup checklist, build methodically, test thoroughly, then refine until the intelligence disappears into the landscape.
Thanks for listening to this episode of Smart Home Setup Podcast. New episodes drop every Monday, Wednesday, and Friday, so you're never waiting long for the next one. If this episode helped you think through your outdoor automation setup or saved you from buying incompatible devices, would you leave a 5-star rating and a quick review? It genuinely makes a difference. It's how other people find the show when they're searching for smart home guidance that goes beyond surface-level gadget hype. And if you haven't already, hit subscribe or follow so you get notified the second a new episode goes live. See you next time.